Okay, video number 2. So we were down here. We were with acetic acid. Okay, in this example of an acid, this one comes off. Okay, when it dissociates, it becomes CH3COO plus Cl minus. However, this reaction doesn't go to completion, and we'll talk about reactions going to completion next chapter. But really, only a portion of this goes over to this side. The vast majority of it stays as a whole molecule. So this would be a weak acid, meaning it does not dissociate or does not break apart completely. So strong acids dissociate completely. Like 100% of it, it's over here. There's none of this left when I'm done. Weak acids do not dissociate completely. So when I'm done with this reaction, only maybe 30% of it has gone to its ions. The rest of it has stayed as a whole molecule, something like that. That's the difference between a strong acid and a weak acid. And that affects pH, because if it doesn't dissociate completely, that pH is not going to be very acidic. That's why vinegar, no matter how much you add to it, how much vinegar you have, or acetic acid you add to water to make vinegar, it's not ever going to be super high pH because it doesn't dissociate completely. Okay, so strong acid, weak acid. Okay, next vocabulary word was diprotic acid. Let me go back to the end of the chapter. Make sure I'm covering these vocabulary words that we talked about. Okay, diprotic acid. I am a fanatic about, what is it called? Now I can't think of the word. Endings and beginnings. Prefixes and suffixes. There we go. Okay, I like this. Okay, diprotic acid. Okay, actually, I think you should know. I don't think it's on the test, but I think you should know what this is referring to. Okay, di means two. I'm using the wrong hand. Protic means proton. So we're talking about a 2-proton acid, right? So that would be like H2O. No, I'm sorry. H2SO4. H2SO3, sulfuric acid, sulfurous acid. Okay, now again, it's not in the book, but I would think you would know this, so you should be able to figure out what is a monoprotic acid. Something with one proton, like HCl, HBr. Okay, and because you're so smart, what would be a triprotic acid? Something with 3 protons, H3PO4, phosphoric acid, and phosphorus acid. There are others, but that's what that means, and I want you to not memorize what diprotic means. I want you to think about that, what that prefix means, and the root word protic is referring to proton, okay, and we talked about that. A proton is really an H plus ion, which is what's going on here. Okay, so that's what that means. Okay, oxyacids. Most of the acids that you deal with when you deal with equations look like this or this up here. But actually, in nature, most of your acids are oxyacids. They're mostly organic acids. Oxyacids are part of an organic compound. It looks like this structurally, but when we write it in shorthand, it looks like this. So when we were talking about acetic acid earlier, like this is what it looks like on the end. And this H gets pulled off and becomes... this whole thing becomes a negative ion, and this plus, H plus, goes somewhere else and jumps onto a water somewhere. Okay, so that's what an oxyacid is. Okay, so, and then the other one was amphoteric, but you know what? I'll talk about that when I talk about conjugate acids and bases, because amphoteric, well, I'll tell you what it is, because I told you this is the video on vocabulary. Amphoteric is when a compound can act as an acid or a base. So when you put something with, and you probably already know this, this is an acid, okay? But water is neutral, so you don't think about it as a base. But when this reaction occurs in the forward direction, it goes to Cl minus and H3O plus. So this is the acid, right? So that makes this, because this accepted a proton going over here, it added a proton, and what did we say all the way back here. What's a proton acceptor? A Bronsted-Lowry base. That makes this a base. Okay? So if I went over, hold on, let me find something else. Let me come up with another one. I'm trying to think. Hold on. Hey, Ron, give me that sheet. See, I told you. I just talked. Give me that sheet by the sink. It has some examples on it, kind of quickly, because I'm actually videotaping, and they're just sitting there listening to me. Oh, he ran over here. All of a sudden, I don't know why I couldn't come up with an example. So I have no idea why I couldn't come up with an example. Let me come up with an example. Here we go. Right here. NH3 plus H2O goes to NH4 plus and OH minus. I'm telling you, I had a brain spasm because this isn't that hard, okay? So here's a water, and when it goes from here over to here, it gave up an H plus to go to the NH3, right? So if it gave away an H plus donor, that makes this an acid, and that makes this a base. Oh, wait a minute. Here, water is acting as an acid. Here's water acting as a base. Water is an amphoteric substance. There are others that can be amphoteric, but water is the standard amphoteric substance. So that's where we're starting with vocabulary. I will go through and we will talk about conjugate acid, conjugate base pairs, and I will talk about ion product constant and the solution's pH scale in a different video because those are all involved calculation. Well, these involve calculations. That involves just a little bit of a process that I want to explain. Alrighty, so if you've got questions, you're supposed to email me. I'm here to help.